All right. Okay, here we go. So this is the exam review, right? Uh, this goes. This refers back to our first lesson, right? We talked about whether or not mapping diagrams show that they are functions or not. This means that the x, the independent, the domain, or set A, all of these cannot repeat. And how does that look? On a mapping diagram, it looks a little bit different. On a mapping diagram, the way you know...
Bus riders, the bus has arrived. Please make your way up to the front of campus if you are not up there already. Again, the bus has arrived. Please make your way to the front of campus. Thank you.
This is set A. This is set B. The way it looks like on a mapping diagram is if there are two arrows coming out of one input. And I forgot to put input. So if there are two arrows, this means that there are two values for one, right? When we input one, we end up with either 3 or 2. So because that is how we can tell this is a function or not, we can now look at this diagram. The mapping diagram represents a functions. Since each number in the input, our input is set A, there is only one mapping to the output, set B. How do you feel? Questions? All right, let's just do another one. Let's do another one that, like this one. So what are we noticing here? That at -2, that value here, there are two outputs, -4 and 0. Because of this, this does not represent a function because there is a number in the input A where there are multiple mappings to the output, set B. Right? We see that in our example. Let's take a look. 2, -3, 4. 4, -4, 7, 0. For the value -2, we get a mapping to the output -4 and to 0. -3 also goes to 0 and 4 goes to 7. But because of this value here, -2, since it goes to -4 and 0, this cannot be a function by definition. And let's just confirm. Boom. Questions, anybody? Yes?
Functions can't share x's, so how are they sharing x's?
Because this -4 and this output of 0 share the same input, -2. So imagine in a graph, when you get to -2 here, when you input this from our set A, you would get...
Jay Bonilla, report to the front lobby. Jay Bonilla, report to the front lobby. Thank you.
You would get two things. You would get the value of 0, because that's in the range, and the value of -4 in the range. That's why. This is how it translates from a mapping diagram into a graph. This is why when we see multiple mappings from the input, that means we're going to get two outputs, and this will fail the vertical line test. How do we feel? Does that answer your question? Does that answer your question? Fantastic. Okay, that is for mapping diagrams. Let's talk about domain for a specific function. There are two things that we want to notice. Whether or not a graph has an open circle on one of the ends, whether it has an open circle or a closed circle. For an open circle, this means we cannot equal the value. Wherever this is sitting at, can't equal that value. Inversely, we can equal this value. Sometimes you can also equal the value if you're in a curve and that curve intersects with some y value and that same x value. So it just depends on the graph. So let's take a look at a couple graphs. For this one, we're asked for the domain. For domain, we are looking to see how far to the left this graph goes all the way to the farthest right of the graph. Now for domain, we have a skeleton to follow. Less than x, less than. Where on the left, this is my lowest value. And this is my highest value. And from there, we just determine which correct inequality, whether it's less than or equal to, or this less than or equal to. So here we go. If we're talking about domain, let's see how far left of the graph we go. Since we're talking about the x value, the lowest x value that I see is 0. Less than x, less than. And when I go all the way to the right, the farthest x value that I see is 8. Now, do we approach these values? Absolutely we do, because of the closed circle right here. So we're going to change these inequalities. Instead of just less than, we're going to put less than or equal to, because we do equal these values. They are part of our solution. And then we just submit. Boom. And again, for those of you that are looking at the examples here after we've solved them, we are not using brackets. That we won't use until Algebra 2. Thank you. For now, we want to master writing domain and range using inequalities. When we get to Algebra 2, we will talk about brackets and parentheses. But that won't be until 2 years from now. Okay? All right. Domain. Let's do range. Now, range, just like domain, works very similarly, except that we are looking from bottom all the way, well, let's visually draw this correctly. We're going from bottom to the top, respectively. So we start the furthest point, or the furthest value that we can see in this graph, all the way to the highest. So let's look at it. And it's the same setup. Less than y, less than for the range. This is my skeleton. I should write that every single time. So on scratch paper, if I get domain, I write my skeleton like this. If I get a range, my skeleton, I should write it like this. And then now I'm going to look for the lowest value, meaning the absolute farthest down value for the range, all the way to the highest value in the range. So what I can see, let me write my skeleton, less than y, less than. I see I'm going all the way down to -7. And in the range, I'm going all the way up to 8. And because it's a curve, it is actually intersecting these values. So I'm going to equal this value. And let me just check up here. Yes, I am also going to equal this value. So my answer for this is -7 less than or equal to y less than or equal to 8. Now, real quick, for those of you asking, well, sir, there's a bunch of open circles. Right, but because we're not looking left to right, it doesn't matter about those open circles. We're literally just looking at how low the graph goes all the way to how high up the graph goes. Questions? Good? All right, let's submit it to confirm. Bam. See, notice how when it gives us the example, it's using these bottom points here at -7 in the range and then 8 in the range. Those are the lowest and the highest respectively. Okay? All right, that is domain and range. Now, using technology, it's the same thing. All we have to do now is just graph it. So instead of them giving us the graph, we have been tasked to graph it ourselves. So I'm going to go to Desmos. Let's look at the equation that we have. F of x is equal to the quantity 1/2 to the x power minus 1. Let's do it. F of x is equal to the quantity 1 divided by 2. Oops. To the x power, and that is minus 1. Okay, cool. So now we are given this graph. So now we need to look at a couple things. Well, first, let's see what we're asked. We're asking to find the range. So my skeleton starts the same way. Less than y, less than. And then from there, I need to see how low I go in the graph. Well, if you notice here, I am approaching some value that I will never ever intersect with. No matter how hard I try, I will never ever intersect with that value, no matter how far to the right I'm going. See? But what value am I approaching? I'm closely approaching. Very good. I'm closely approaching -1. That's the lowest that my graph will go. And now, how high up will my graph go? What are we noticing? No matter how far I keep going up, it's going forever. Mathematically, we call that infinity. So because I never equal -1, I don't put the equals bar underneath. And same thing with infinity. I will never approach a value for infinity because there's always a greater number out there. So this is my answer. -1 less than y less than infinity. Same thing if I get an equation like this. Use the graphing technology to find the range of this function. I got it. Here we go. It's a very simple quadratic function. We're just looking for the range of x squared. Okay. So if we're talking about range, then we know that we're looking for the lowest to the highest. So I'm going to give my skeleton an equality. And because I am looking for the lowest range value, what's the y value here? 0, exactly. Do I equal that value? Yes, I actually intersect that range value, so I'm going to include that as part of my solution. And how high up is this quadratic going to go? You'll notice that no matter how far up I keep going, what am I going to go on forever? Absolutely I am. So mathematically we say that we are heading towards infinity. So my solution, 0 less than or equal to y less than infinity. Now, there's another way that we could say this. If I didn't want to type that all in, I could also say that all my y values are greater than or equal to 0. Think about it. My y values that are greater than or equal to 0. 1, 2, 3, 4, 5, and I keep going all the way towards wherever, even all the way up to infinity, but this will still hold true. All my y values that are greater than infinity. This is another way that I could say this. Same thing with the last example. I could have also said, this one was for that exponential. I can say all my y values that are greater than -1. That is another way that I could have said this for the exponential function. And who knows, it might come up on an exam. Can I answer any questions? Are we okay so far? Okay. All right, I gave you a bunch of graphs here. What type of function is this? Well, it's some U-shaped going both in the same location. So what do we call this? Quadratic. Okay, let's try another one. What type of function is this? It's only increasing, right? It's only increasing, meaning we call this an well, it's not a quadratic, right? Because it's either decreasing, increasing, or increasing, decreasing. What do we call this? Very good. This is an exponential function. Last one. What type of function is this? It's a line. I told us to remember something specifically. It's a linear function. Right? Now, if you want, this is how I've done it in the past. If I'm looking for linear, I think of L for line. For exponential, I think of an increasing line that looks like this for E. And then for quadratic, I think of a U-shaped function. Just a quick shorthand on how to remember the differences between the, and that's the only ones that we're talking about for Algebra 1. It's the only 3 parent functions that we talk about in Algebra 1. Okay? Linear, exponential, quadratic. Knowing how each one of them looks is super important, especially on the upcoming exam. Okay? Cool. Questions? All right. This one we called it parabola features, but in reality, I just need you to tell me a couple things. Where the graph crosses the x-axis, where the graph crosses the y-axis. In this case, it's asking for when the graph is crossing the y-axis. How many points is that? 1 or 2 points? All right, it's 1 point. I'm noticing it's right there. So all I need to do is tell Delta Math exactly where it's at. That is 0, 8. Good? Everybody okay? Let's just do another problem because I want it to, nope. No, you're not gonna get a problem. There you go. You'll get this other problem. Using the graph, determine the coordinates for the zeros of the parabola. I told you whether you get the word zeros, solutions, or x-intercepts, they all mean the same thing, where the graph crosses the x-axis. So in this case, I'm seeing 2 points. 2 points here. It is -7, 0, and -5, 0. Nope. Questions? Anybody in Algebra 1? We're good? All right. Here we go. You were asked to find whether this function, this quadratic, has a minimum or maximum. Well, personally, I can tell you that it's going to be a minimum. We talked about this on Tuesday, right? Say it again, louder. Yes, if the x squared portion has a negative or not. If it's a positive, if that x squared is a positive value, then we know it's going to be a minimum. If it's a negative, then we know it's going to be a maximum without even having to graph it. So for now, I can say that this is going to have a minimum, but let's just graph it. F of x is equal to x plus 4 quantity squared plus 5. Cool. So now when it's asking for maximum or minimum, we want the y value. So all you have to do is go down to either the lowest if it's the minimum or the highest if it's the maximum, right? In this case, it's a minimum. What's the minimum value here? In my example, I'm seeing that it is a 5. What's up? So let's just do another one. Nope. This one. Let's do this one. Let's graph it. Real quick, do I have a minimum or a maximum? Maximum, right? Because x squared is positive or negative? Negative. So that should be the first thing. Without even having to graph it, I should be able to say that at least. So there's going to be a maximum, but now let's actually graph it so we can get an actual value for the maximum. Negative x squared plus x minus 4 plus x, plus x minus 4. Cool. My maximum value, what do I get? According to my problem, I get negative 3.75. And yes, it can be a decimal. So negative 3.75. Let's submit it. Bam. And again, here's what delta math is saying. Because the leading coefficient is negative, we know that we're going to get a maximum. And inversely, if our leading coefficient, the number in front of the x squared, is positive, then we know we're going to have a minimum without even having to graph it. Yeah, that was the one that I got. Yeah, look. The y value there is negative 3.75. Questions? Alrighty. 2 more. I need to determine whether or not this graph is a function or not. With graphs, it's easy because all they have to do is pass what? Say it louder. Vertical line test, exactly. Does this pass a vertical line test? You sure? If I were to draw individual lines, will it pass a vertical line test? Yes, it will. Look. Only passes it every single time. Let's do another one. Will this one pass the vertical line test? Yes, it will. So is this a function? Yes, it is. Let's try another one. Will this one pass the vertical line test? It will not. So this is not a function. Well, is this a function? No, because it won't pass the vertical line test at all. So that's not good. Okay, last one. So if a function can't, if we're calling it a function and it can't, if it passes the vertical line test, that means what value doesn't repeat? The x's, exactly. So this means we're looking for an ordered pair that does not represent a function. So we're looking for an ordered pair where what value repeats? If we're looking for it to not be a function, what value do we want to repeat? The x's, right? So let's take a look at the first one. 7, -9, -5, -9. Which one would I'd probably select this one. What number repeats on that first one? The -9. And if that x value repeats, then we know it's not a function. So then there we go. Okay, which ordered pair represents a function? So that means the x can or cannot repeat? Cannot repeat, exactly. So let's take a look. Option 1, 1, -7, 8, and 1. Can't choose that. That one's not a function. The next one, -1, -9, -8, -4. None of the x's repeat. We're looking good. Let's check the other two just in case. 6, -5, -5, -2. Nope. And let's check the last option. -3, -3, 7, and 0 for the x values. No. So my only option is B. Because x does not repeat in any one of those ordered pairs. How do we feel, everybody? Good. I've come to the last part of why so. How can I help? Mm-hmm.
I would always confuse like whether it's supposed to have functions repeated also.
The wording? Uh-huh. Oh, so we're going back all the way here? These?
Yeah, I would always switch them, but I think
You feel better about it? Yeah, so again, if I was doing these problems, I would just start off by maybe underlining or writing which one I'm looking for. So it says range. Mr. Quiñones says that there's a skeleton for range. Less than y, less than. Okay? And then from there, I'm looking at the lowest ranges bottom up. So I'm looking at the bottommost point or the bottommost y value, and that's at -8. And the highest y value here is 7. Do I approach these values? Well, look, I actually cross into that -8 value. So it's part of my solution. And same thing with this 7 here. I actually approach it so I can equal that value. So let's just put it in. Let's see if I'm even right. -8 less than or equal to y less than or equal to 7. How do you feel now? Better? Anyone else? Questions? All right, everybody. That's it for my tutoring today. That is how we do the review.